Hello, today I'm going to talk about what is DataOps. So in traditional analytics teams, the need for or where the need for DataOps came from was in the new ways of working where we need to deliver deliver analytic solutions at speed and with quality. There are certain fundamentals which help teams move faster, and one aspect of that those enablers comes from DataOps, which is essentially a combination of agile ways of working, DevOps practices, which is CI/CD, and then we have lean manufacturing, which has more to do, from which we take the concepts of observability and monitoring. So you combine these three, and that gives you some fundamentals which are then called as DataOps, which allow teams where it was previously perhaps cumbersome to deliver solutions at scale and at speed. And we take all the best practices that have been learned in the software development community over the years, and you bring them into the context of data analytics and implement them to develop agility and speed of delivery. So let's talk about these components one by one in relation to data analytics solutions. So the first one being under agile ways of working would be MVPs and hypothesis. So any analytics solution requires to break it down into smaller pieces and try and see the essence of the solution. Does that really provide the intended value or not? For example, a business user and the analytics team think that a specific ingesting data from a specific source and running certain KPIs is going to give them insights which will help with a pricing strategy, let's say, right? So but that's a hypothesis. So what needs to happen, there's a lot of test and learn which happens where we take a small portion of that, we try it out, and then we see if it works, and then we further refine and build on top of that solution. So the ability to break down a big problem statement into smaller chunks is extremely useful, especially in the analytics space. Secondly, we have prioritization. In a lot of cases, analytics teams are shared across the enterprise, and it requires for them to be able to prioritize which activities need to come first or which solutions to deliver first, which is usually a tough conversation to have. Then we have develop iteratively, which means, again, we talked about MVPs before, the ability to roll out a small piece of chunk, a small code, a small change, a small feature iteratively and very quickly. This ties into DevOps as well, but the software engineering or architecture principles should support iterative development. For example, if just rolling out a solution requires considerable effort, then you would think twice before rolling out a smaller piece, and you might as well say, okay, let's develop a reasonable size solution because we save on the effort of doing this activity again and again. And we have finally quick feedback. So again, analytics solution, a lot of these are test and learn. You implement something, you see if it's giving value to your business users, you come back and improve on that. So quick feedback is really important. So of course there are a lot of other principles in agile ways of working which are tremendously helpful, but these were the few important ones which I felt are really crucial and might come under the, would be more applicable under the context of DataOps. So the second one is, of course, DevOps. Now DevOps is extremely required in case, especially for analytics solutions, where the deployment of our ETL pipelines or visualizations can sometimes take considerable time, especially if these are cross platforms, right? So the key enabler here is to deploy your ETL jobs, pipelines, changes to it without manual intervention. That process has to be automated, because as soon as you have this activity or you have as many manual steps in there, it's going to take a lot of time in deploying these solutions, which is going to slow down your test and learn ability. Then to facilitate that, of course, a very good practice is infrastructure as code, which is kind of one of the fundamental things that in DevOps or SREs that happens. So infrastructure as code, especially if you're using any of the main cloud vendors, Azure, AWS, or GCP, then you have the ability of having your infrastructure as code in terms of setting up and tuning down environments becomes very easy. The ability to generate test data needed. A lot of analytics solutions, of course, the biggest ingredient is data, and you need a lot of different varied sets of data to see if your analytics solution is performing well in a lower environment, in a non-production environment. So the ability to generate that data and reuse it is extremely important, without which teams often take a lot of time in just creating the data they need to validate their solution. Run atomic automated tests. Now this is really crucial. So a CI pipeline, we talked about deployment, but just deploying isn't enough. There need to be some tests validating your ETL job or whatever job you have, curation, cleansing, modeling, that whatever activities or business rules that are happening in those jobs are being validated through an automated test. Initially, teams assume that there isn't going to be much work in terms of test automation, but as you grow your pipelines, you will realize there's a lot of business logic that gets baked into these, and if you don't have automated tests running on every commit, then sooner you would run into problems where there's a lot of test coverage which needs to be done, and it becomes a very cumbersome exercise to roll out new features. Finally, lean manufacturing. The topic is quite wide, but what is relevant to DataOps and data analytics is the ability to have observability built into the data pipeline, or in lean manufacturing on the assembly line, and for analytics on the data pipeline. So as data flows through your data pipeline in your prod environment, having an insight into the health of your data across the pipeline is extremely valuable. Now we talked about tests running in your CI/CD while deploying. Now those are important, but equally important is this observability in production, because the code or the business rules that you write for your ETL pipelines are just half the story. The remaining story is the data that you ingest, which we know from experience is always going to throw new surprises at us. So observability of your data pipeline, or health check of your data pipeline, or anomaly detection is going to be extremely crucial, and that's the real test which you go back and refine your pipelines and your tests. And having alerts and raising those alerts is extremely important as well, because then that gives an understanding of teams as to if there is something wrong, then they go back and fix those anomalies. Now let's dig deep a little bit into these concepts one by one, and let's start with DevOps. So in terms of DevOps, we talked about deployment and CI/CD. So in your data pipeline, you might have typical stages. You will go through ingestion, cleansing, and all of the good stuff, eventually till visualization. So across all of these stages, what you'd want is the deployment process has to be very smooth, and which is essentially a CI pipeline. Now in a CI pipeline, you would have, again, the good practices of understanding your development practice in terms of what features we are developing, what is the business ask, what is the expectation, coding those, having automated tests, and deploying automatically. Standard tests that you would have, standard stages that you would have across a CI pipeline. And while data analytics and data engineering is different than how you work with, let's say, web applications or microservices or services in general, but these stages still remain valid. And at times I've seen teams not necessarily thinking, data is really an exception and we don't need to go through this, but the reality is, if we compromise on these processes, you pay the price later on. That tech debt that you inherit has to be paid then at some point in time. You just don't get rid of it just by not doing these steps. You'll have to pay it off, and perhaps a lot times over if you miss these. So in this your CI pipelines, to get your CI pipelines to run efficiently, the first thing you would need is test data. For developing also you would need data. For different types of tests you would need data. After deployment sanity you would need data. So test data is one of the big problems and challenges that teams face in terms of analytics data pipelines. So it's extremely important that you have a capability to generate that data. Now it can be done in multiple ways. You can have generated data generated from source. You can have that data mocked, saved somewhere, loaded wherever you want, and there are different techniques about it which we can talk about at a different time. But bottom line, the ability to generate that data or have that data when you need it is extremely important. Then the next one is having tests running. So now, as we said earlier, there are two types. The type of tests, one is that across these stages in your CI pipeline you should have tests, which is perhaps you should have static code analysis, you would have unit tests, you would have what we call component tests, you may have integration tests running across your pipeline. So all of these tests would be part of your CI/CD process. The next set is, which you see over here on the screen, is between stages, which is essentially running in production, and that is also, as you mentioned, is an important part of the process. Then we have deployment. Deployment of your changes across different environments, dev, staging, prod. Again, this has to be an automated process. If you have manual steps in there, experience where it takes a lot of effort to do that deployment, and hence teams tend to shy away from doing smaller builds, smaller changes, because there's a lot of rework that then needs to be done. So those were a lot of principles, common ones, which come under DevOps. Now let's talk about observability. So again, back to our pipeline here. Observability, we need to have tests and matrices running across the data pipeline, which give you insights in terms of what problems do we see, are there any failures, do we have any data missing, is there some obvious errors that we see. For example, you generally expect, so general categorization here is validation of business rules usually is tricky, so you don't necessarily do that in production, but general KPIs in terms of usually we expect these many records on average. So if there is a loss, you would raise an alert to know that something's happening. In some cases, certain you would treat your stages across your pipeline as contracts, where you look at this stage, the expectation of the data is ABC. So column checks and checks on your columns, field validations in terms of unwanted data, mandatory fields missing, so on and so forth. So these are some common ones which you would have at this stage. And a very big and important benefit of observability is to show this to your business users. A lot of times, almost every data analytics team faces this challenge where business users come back and say there's something wrong with your analytics solution. Anything they see there is a mismatch, the assumption is there's something wrong with the analytics solution, because of course that's what they're seeing. They're looking at that anomaly on an analytics dashboard. By providing observability into the health of your pipeline, it gives them a lot of confidence in terms of the data that they are being served isn't necessarily something that there's perhaps something going wrong in the pipeline. Perhaps there is something, in a lot of cases that is what happens. There's the data you get from your source systems has an issue, and you've tried to curate it to some extent, but still you can't really eliminate a lot of issues in your source data. If there's something missing, it's just missing. So that's the data anomaly part which they see and they question, and having this observability takes away that doubt and builds that trust in the analytics solution is extremely crucial for keeping your business users and customers happy. Moving on to the last section about agility. So we talked about a few things around agile ways of working. One aspect which we didn't discuss was around having centralized teams versus decentralized team for analytics, which is somewhat relevant to the data mesh architecture and conversation. So having traditionally you have a centralized analytics team which develops BI dashboards, domain models, data models, and dashboards, etc., for the entire organization, for the entire enterprise. And so it does have some pros there, where because they are all experienced engineers and they're able to build relatively more robust solutions which are more scalable and maintainable, because that is what they do, and they tend to reuse a lot of their stuff because it's essentially the same team doing the same thing. However, the challenges that do sometimes happen is they usually almost always become a bottleneck in terms of the release of features is not as quick as teams would want them to be, and so they don't necessarily sometimes get a lot of time into innovate and do POCs. And with the data with the data analytics landscape, the rate of change is quite high. So every 1 or 2 years new concepts are coming in, the industry is maturing as a whole. So all these concepts around data fabric, DataOps, data mesh, and the changes in cloud architecture and the way we do warehousing, all of these are consistently changing, and these are very recent changes or innovations that have happened in the very last few years, and these will continue to change. So innovation is a very big part of analytics teams, because they don't have a choice. They have to innovate and very rapidly look at and revisit their tech stack. Also, it becomes harder to deliver, of course, because data analytics cannot exist in a vacuum. It needs to get a lot of data from source systems. Of course, that's you're just getting data from there or from external parties now, and that requires a lot of collaboration. So having one central team developing everything, and then they have to coordinate with a lot of different people, sometimes that becomes a challenge, and it becomes hard to deliver features iteratively, which I feel has to do more with having a centralized team. Now, the other way you can organize your analytics team would be have distributed people. So you would have perhaps one small central team which just does some very basic enablers, but then everyone else you have separate splinters of teams that work very closely and solely just for specific business cases and business users. Or in the data mesh concept, it won't be necessarily for business users, it would be for individual products. So you would say this is a customer's analytics product, this is a finance sales product, this is a HR solutions or product, right? So you would organize your teams around business functions and analytics for those business functions. So that way they are more closely working with specific groups, and they are more closer to the problem statement instead of one central team. Now, it does have pros with they can develop MVPs faster because they understand the business better, and it's they're more closely aligned to their business, and that helps with them generating effective solutions compared to a centralized team. And that's kind of one of the biggest advantages, because a lot of times the expectations of the business users and the central team are not necessarily aligned, because the central team is serving a lot of people, and each business user sometimes has very unique needs. The cons, however, are to keep consistent development practices. In a distributed team, of course, different teams might have slightly different ways of working, and that's fine, but there have to be synergies between teams. We don't want to do a lot of rework, and that is where the challenge comes in, that teams end up using each other's work instead of reinventing the wheel every time. Learning curve sometimes can be a challenge. Again, if it's a centralized team, they have all the skills they need. If you have offshoot sprinters or working on specific product domains, then it becomes more of a challenge to have all the skills required in that team. For example, infrastructure related, analytics related, data engineering, ingestion, modeling, if you have data science solutions, AI ML. So there are a lot of different aspects and different types of roles that exist in a data analytics solution, and getting all of those expertise in all these splinter teams then can become a problem. And of course, you may have duplication of effort in this scenario. So there is no one best answer, obviously, for the situation. And I think as organizations grow and their analytics function changes, it's only natural that they reconstruct their team structure around analytics. Perhaps, usually, of course, a lot of times teams start with a central team, which sometimes makes sense, of course, but then as they grow, they realize that perhaps it's too big for one central team to do, and teams need to be closer to their domains and perhaps split it up. But it all really depends on the history and the context and the culture of the organization and the kind of solutions they are delivering. But just on a high level, these are two different design patterns and the pros and cons that they can have. So, concluding the whole exercise or the discussion we just talked about: number one, DevOps practices. We talked about automated deployment. We talked about automated testing. We talked about data generation for DevOps. We talked about lean manufacturing, under which we mentioned observability, and finally talked about under agility, centralized and decentralized teams. I hope you enjoyed and you got to learn a few new things. If you found this video useful, don't forget to like and subscribe. See you next time.